We often treat fungal growth as an invading force, an infection to be scrubbed away. But those dormant spores are already everywhere. They only react when a building loses control of its internal environment. The true root cause is hygrothermal failure, a breakdown in the structure's ability to manage heat and moisture. Looking at this cross-section of a porous building material, we can see the critical metric for biological growth, the water activity threshold. Once the moisture saturation level of a substrate crosses 0.80, opportunistic fungi begin to rapidly colonize. That moisture breaches a structure through three specific pathways: sudden bulk water intrusion, continuous air-transported moisture, and slow molecular vapor diffusion. A standard inspection hunts for visible colonies on drywall or wood. A professional forensic evaluation hunts for the moisture dysregulation that makes those colonies possible in the first place. This data overlay shows the cycronitric formula, calculating actual vapor pressure based on fluctuating relative humidity. This relationship dictates exactly when and where condensation will occur inside a building assembly. To identify these failure points, we have to systematically deconstruct the building's anatomy, evaluating the exterior perimeters, the interior compartments, and the structure's mechanical lungs. Treating a facility as a static object guarantees failure. It is an active, interconnected psychrometric matrix. We begin our inspection at the lowest elevation. Crawlspaces and basements are the primary subgrade infiltration zones, directly exposed to continuous ground moisture. Here, a polyethylene vapor barrier physically blocks the upward evaporation of groundwater. But structures aren't hermetically sealed. Warm air rising creates negative pressure at the base. This stack effect actively draws moist air upward through unsealed seams in the barrier. Before biological growth appears, we look for physical evidence of this pressure. Efflorescence, chalky white mineral deposits left on masonry surfaces, proves that hydrostatic pressure is actively forcing water straight through the foundation walls. From the subgrade, the inspection moves vertically to the uppermost extreme of the envelope, the roof systems and attic spaces. Widespread fungal growth on attic sheathing is rarely the result of a direct hole in the roof. This 3D wireframe reveals thermal bypasses. Warm indoor air escapes into the attic through unsealed penetrations. Colliding with freezing roof sheathing, vapor condenses into water. This freezes into ice dams, blocking drainage and forcing melting snow back under the exterior shingles, fueling rampant mold growth. Unmanaged moisture causes the exact same degree of structural compromise as a catastrophic bulk water leak. Hygrothermal failures at the extreme top and bottom of a structure create vertical moisture corridors. The occupied spaces caught in the middle are inevitably compromised. Moving into the interior space, we examine the exterior walls and the weather-resistive barrier. Windows and doors are deliberate, necessary interruptions in that continuous barrier, making them highly vulnerable failure points. This cross-section of a window frame illustrates what happens when exterior flashing fails. Rainwater bypasses the seal and travels downward, slowly saturating the interior wooden wall strophic burst pipe. A slow, persistent pinhole leak inside a wall cavity provides a steady supply of liquid water that goes unnoticed for months. When you see peeling drywall, bubbling paint, or discoloration, the structural materials behind the surface are already thoroughly saturated. Aesthetic damage is a late-stage symptom of trapped interstitial moisture. Because this moisture remains hidden, diagnostics rely heavily on the human nose long before the growth actually breaches the surface. Relying exclusively on visual confirmation is a flawed protocol. If a biological colony is visibly blooming on an interior wall, the internal cavity has already reached a state of advanced hygrothermal collapse. The most potent vector in any building is the HVAC system. It actively circulates air across every isolated compartment, connecting the entire structure. The interior of an air handler operates as an ideal biological incubator. It provides a dark, enclosed environment with a continuous supply of organic food in the form of accumulated dust, alongside a constant source of water. Inside the air handler, primary failure nodes are the evaporator coil and condensate drain pan. Warm, humid air crossing the freezing coil condenses into droplets falling into the pan. If the drain clogs, the pan overflows, creating a stagnant pool that saturates surrounding insulation. In the distribution network, the primary threat is unmanaged dew point. This cross-section shows an uninsulated metal duct in a hot, humid attic. When the duct's surface temperature drops below the attic's dew point, condensation forms continuously on both exterior and interior walls. This moisture buildup is exacerbated by short cycling. When an oversized AC unit cools the ambient air too quickly, it shuts off before extracting the remaining humidity from the building. That suspended moisture is left inside the airstream, elevating the water activity level and fueling systemic fungal growth along the entire duct network. The ultimate consequence is mechanical distribution. The system weaponizes the biological growth, actively blowing spores and particulate matter into sterile, occupied zones. Mechanical systems operating without rigorous dew point and humidity controls act as superspreaders. They turn highly localized moisture events into facility-wide contamination. A building is not a collection of static, separate rooms. It is one interconnected thermodynamic system, where an isolated failure triggers an immediate chain reaction. A blocked soffit vent creates an ice dam that rots an exterior wall. An oversized air conditioner fails to dehumidify the air, causing condensation to pool on the interior windows. To trace these chain reactions, human visual inspections must be augmented by thermal technology. This infrared thermography heat map highlights a massive cold spot, a thermal bridge spanning an entire wall assembly. But thermal imaging has limits. It only identifies temperature anomalies. A cold spot simply generates a hypothesis about where moisture might be accumulating. We must secure empirical confirmation. This side-by-side verification cross-references infrared data with a pinless moisture meter, proving the presence of liquid water within the material. Executing mold remediation without correcting the underlying hygrothermal failure is a tactical failure. It guarantees the contamination will return. Environmental management requires sealing the envelope, meticulously managing the dew point, and maintaining uncompromising mechanical discipline. That is the only way to ensure the long-term operational readiness of any facility.